Troubleshooting the logical network, making sure that you can connect via IP. Now, some of the TCP/IP utilities would be things like ipconfig. Set your IP address, your subnet mask, default gateway, other configuration. We're going to see some switches for that. That's an important one. FTP for transfer files. NetBIOS over TCP/IP statistics. It should be NBTstat, not NBstat. Little typo there. NetStat, network statistics. NSLOOKUP to verify DNS information on a remote site. Ping to test for connectivity. Traceroute, I know I've changed the order here. Traceroute to test connectivity along each path in the route. Lets you know the path taken. Route shows you the routing information, how you're going to get there, what router is going to be used, how many hops you can expect to take. And that's pretty much beyond scope of this exam outside of knowing the command. And finally, Telnet allows you to communicate to a remote device and interact with it in a terminal emulation mode. So ipconfig, used to display and monitor TCP/IP properties. Probably the most important switch here is /all. See all the properties, not just the IP address, the subnet mask, and the default gateway. If you just do ipconfig, that's all you see. If you do all, you see all the statistics. You see the DHCP server, you see the DNS servers, you see the NetBIOS name servers, or Win servers if you please. Release releases an IP address. Renew grabs an IP address. If for some reason a computer is incorrectly registered in DNS, because modern operating systems using the IP address, when you get an IP address, the computer will register itself, or the DHCP server will register that computer in DNS. Well, occasionally a mistake is made. So you can do ipconfig /flush DNS to clear that entry, or display DNS, or register it in DNS if for some reason it hasn't been registered. So here's an example of ipconfig, and this is looking like ipconfig /all because you're seeing a whole lot of information, not just the IP address, the subnet mask, and the default gateway. You're seeing the MAC address. Oh, and the only way you're going to see the MAC address is if you do the /all. MAC address is shown as the physical address or MAC address, depending upon the version of Windows. Now, ping is the packet internet groper. What a pleasant sounding name. It's used to test for connectivity. Sends a packet to another computer to test whether or not it can receive it. You're really sending an echo request to that computer, and that computer is going to send back an echo reply. That's part of the ping. And you do it 3 times normally, sometimes 4. In case of Windows, it's 4. Other operating systems do it 3. And you can use the NetBIOS name, DNS name, or the IP address to ping with. Now you might notice it says you're pinging with 32 bytes of data. Little trivia for you. Any of you know what's in those 32 bytes? It's just the alphabet A through Z, A through F. That's all. Nice and simple. It's nothing special. But it's one of those things you can ask your network people. They probably don't know it either unless they've actually used a protocol analyzer and sniffed some of the traffic. Now, network statistics displays details of your TCP/IP connections. What ports are open and listening? Which ones are connected? The net command can control services, network shares from the command line, and the most common is probably net use. An example of that might be net use space z colon space / and path out where you want to connect to space / persistent : yes. And that says connect to drive Z, this network share, / C : other computer name, / and then it's pathing within it. And then I put a switch in there, that / persistent : yes, saying remember this. Even when you reboot the computer, reconnect this share next time. Okay, you don't need the persistent in there if you only want to use it for that one session. But I find when I map something, I tend to want to use it again later. NSLOOKUP. NSLOOKUP verifies communication with the DNS server, usually at a remote site. And it can be used interactively or as a command. I tend to use it interactively, do an NS lookup, set type equals all, so I can see all the records. And then I type in the name of the site I want to get to. Just Microsoft.com, and it's going to talk to their DNS server and show me what they have. What machines are there, who's going to handle name resolution. Now, traceroute, this really should have been right back there with ping, but they put it here for some reason. It's to verify the network path between two systems. When you do a traceroute, you're still doing the same as ping, but you're looking at each hop along the way. You see every router. If you're not connecting with ping, you do that traceroute, you might see where it fails. And if that's within your environment, you might be able to get the network team to fix it. If it's at the recipient side, they might be able to fix it. If it's somewhere in between, there may not be a whole lot that you can do. Now, other client connection issues, secure connection protocols. SSL, TLS, good for going to websites. IPsec, good within your own domain for communicating securely. FTP to send and receive files, not secure though. Email, we've got SMTP for sending mail, POP3 for retrieving mail. SMTP uses port 25, POP3 uses port 110. If you want to manage mail on the server, which can allow you to view it, effectively bring it down, you can use IMAP4, that's port 143. Firewall ports. Well, firewalls block everything. You open ports to allow in communication that you desire. Everything else should be blocked. Remember, firewalls deny all. Nothing comes through except for that which you explicitly allow. NAT devices, network address translation, takes a public IP and converts it into a private IP. You can have lots of computers behind your NAT router. They all have their private IP addresses, 192.168 dot something. And you have one public IP on the other side. They all share it. Help manage the depletion of IP addresses, but provides a lot of security too. A proxy server acts as the middleman. You send data out to the proxy. It puts its header on it. It sends it out to the endpoint. That endpoint, if it's a bad guy, they want to attack you, they hit the proxy, not you. It's in between. It keeps you safe. Plus, proxies tend to have another bonus feature. Most of them also cache content. So when something comes back, it stores a copy. So if someone else asks for the same thing, you don't have to go over that slow WAN link. It's there in the server, and it just sends it back to that person, nice and fast. Now, Windows has some built-in network diagnostics, built into 7, Vista, and into some of the newer server platforms. It helps to automate the troubleshooting, diagnose, and repair some problems automatically. You can do these steps manually, but it can do a lot of them for you. You can release an adapter setting, try to renew it. Instead of having you manually do it, it'll do it for you. And this is what it looks like. There it is in 7. And in this case, it ran some diagnostics and says the local connection to adapter is disabled. And what would you like? Were it to try to repair those as an administrator? Probably just enable the adapter and grab an IP address. Or would you prefer to explore some additional options? Well, if you let it try those repairs, it should probably enable it and grab an IP. If you want to do it yourself, close that and go to that adapter and enable it yourself, and hopefully it'll grab.